When you top the glass of a modern screen, the response feels effortless. It reacts like a physical object. But behind that glass, building those flawless interactions used to be a chaotic process. For over a decade, creating an interface meant stepping into the role of a micromanager. You had to instruct the operating system on exactly where to place every single pixel and dictate how it should react to every possible human touch. Look at the early era of iOS development. To build these older layouts, engineers wrote hundreds of lines of code just to display basic text and lists. Everything was a manual calculation. As applications grew larger and more interactive, this manual method of building software hit a breaking point. The sheer volume of code became too fragile to maintain, forcing Apple to secretly rewrite the rules of how software is designed. The old system was built on a concept called imperative programming. It is a system where the developer writes out literal, step-by-step commands for every single action the device takes. If you wanted a simple button on screen, you couldn't just ask for one. You wrote a command to create the button, another command to position it, a command to set its color, and another to define what happens when a user taps it. The primary weakness of this method is maintaining the state, the live data behind the screen. If a user logs out, you have to write explicit instructions to go back and hide that specific button. If you forget that single line of code, the logic breaks and your app fails. Highly trained engineers were spending large portions of their week acting as mechanics, hunting down UI bugs and untangling fragile code, rather than inventing new tools for users. Apple engineers looked at this bottleneck and asked a specific question. What if developers didn't have to build the user interface at all? What if they only had to describe it? This is the premise of Declarative UI. To understand the exact difference between the imperative system and the declarative system, you just have to look at a restaurant kitchen. Imperative programming is like walking into that kitchen and micromanaging the chef. You tell them exactly how to chop the onions and what temperature to heat the pan. Declarative programming is just handing the waiter your order ticket. You state what you want, the kitchen figures out how to make it. SwiftUI is that hidden master chef. You declare your intent, and the system automatically handles the thousands of complex background calculations required to draw it on your screen. Under the hood, this entire system relies on a single mathematical rule. The user interface is simply a function of its state. Because of this rule, your app screen is no longer a static object that requires manual updates. It operates as a live, automatic reflection of your underlying data. Here is how that works in practice. We define a piece of data called state. Let's say whether a user is subscribed or not. We declare a rule. If the state is false, the button is red. The framework constantly watches that data. The exact millisecond the user subscribes, the state becomes true. SwiftUI automatically destroys the old view and redraws the new one. By making the UI a strict function of state, SwiftUI removes the need for manual updates and the hidden logic paths that cause bugs. It is pure engineering elegance. Removing that manual labor directly alters the economics of software development. Large, complex applications can now be written, tested, and shipped using a fraction of the code they required a decade ago. Take the dense interface of an Apple Watch. In the past, squeezing that much information onto a tiny screen required tedious layout math. Now, state-driven rendering handles the spatial placement automatically. And this scales directly to the spatial computing environment of the Vision Pro, which relies on this same framework to manage overlapping windows and 3D environments without manual positioning code. At a micro level, complex animations, like realistic spring physics bouncing off a screen edge, can now be triggered by adding a single word to the code, rather than weeks of mathematical modeling. Apple effectively returned thousands of hours to developers. That time is now spent refining how an app feels to the user, rather than fighting the code that draws it. We used to believe that great engineering meant writing complex, intricate instructions. Today, we know that true elegance is hiding that complexity. This approach mirrors Apple's broader design philosophy, presenting a simple, pristine exterior that masks an immense depth of technical processing. SwiftUI takes the most punishing parts of computer science, managing rendering loops and state variations, and dissolves them into a clean declaration of intent. In this declarative world, Developers are no longer mechanics forced to fix tangled wires. They are architects, finally free to focus on the human experience of their software, rather than the plumbing that keeps it standing.